This video is polar coordinates part 3. This is found in section 10.7. Now we're going to concentrate on equation conversion, and first we will focus on taking rectangular equations and changing them to polar equations. All right, so a few basic guidelines. Whenever you can, substitute r cosine theta for x and r sine theta in place of y. And then whenever possible, solve for r. All right, here is an equation of a simple parabola, y equals x squared. Okay, so we'll just follow the guidelines that we did a minute ago. So we are going to substitute r sine theta in place of y and r cosine theta in place of x. Okay, so we have r sine theta is equal to r squared cosine squared theta. All right, it will be okay to divide by r in our solving process. So we'll have the sine of theta is equal to r cosine squared theta. And to solve for r, we'll divide both sides by cosine squared theta. So we have r is equal to, this is not the preferred form to leave it. Let's get rid of the denominator. So you could think of that as secant squared, since there's an identity for that. Or we could think of putting one of the cosines under the sine and then having one cosine left on its own. And so then the most common answer you're going to see here is this is equivalent to the tangent of theta times the secant of theta. Okay, so that would be the polar form of the rectangular equation y equals x squared. All right, now let's look at a circle. All right, this would be a circle where the center is the origin, and r squared, radius squared, is 49, so the radius is 7. This is actually a complicated equation because it has the two variables in it and they're both squared. If you get to where you're working with this in calculus, this is very difficult to deal with. And the polar equation is going to be much better. All right, so x is the same thing as our cosine, so we'll be squaring that. And then y is the same thing as our sine theta, and we're squaring that. So we're going to have r squared cosine squared theta plus r squared sine squared theta being equal to 49. If I factor out the r squared, then I have cosine squared theta plus sine squared theta being equal to 49. And of course, cosine squared plus sine squared at the same angle always equals 1. So we're left with r squared being equal to 49. Now, you can skip all these steps if you like, right? I didn't want to put too many steps at the beginning to complicate things, but where I'm saying you're substituting r cosine theta for x and r sine theta for y, you can also substitute r squared for x squared plus y squared. Right, so that is another thing. So up here where I had x squared plus y squared, I could have put r squared. And if you have that memorized, it's perfect. All right, and then we will take the square root of both sides and say that r is equal to 7. We don't have to do positive or negative 7. When we look at graphing, that becomes a little more clear. But all the points who have an r value of 7 could also be written with an r value of negative 7. It goes back to how there's multiple representations for any one point. Okay, so that's the polar equation for that circle. And you can see this is very simple. You just have one variable and it doesn't have any exponent at all. So that's why in calculus you will work a lot with polar coordinates for things like circles. Okay, lines Here's two examples. This one's a horizontal line and that one's a vertical line. They're kind of sort of similar. So we're going to replace x with r cosine theta. And so that's equal to -5. And then we're solving for r whenever possible. So in this case, you would divide by the cosine of theta. And that will give you that r is equal to -5. And we're going to say times the secant of theta. So there you go. Not that much of an improvement. Okay, y equals 3. Y is the same thing as r sine theta. So we'd have that equal to 3. And to solve for r, you're going to divide both sides by the sine of theta. So you're going to end up with r equals 3 times the cosecant of theta. Okay, so this is a vertical line. This one's a horizontal line. All right, just a general line. Here's an example of that. 5x plus 2y plus 1 equals 0. Now, this is in general form, which we don't use a lot for our lines, but you could. That's where you don't have any fractions or decimals, and if possible, and it's set equal to 0. Now, this line, if you wrote it in our slope-intercept form, would be y equals -5/2 x plus 1/2. That's the form you're most used to. Okay, well, in any case, let's put this one in polar form. Okay, so we will have 5 times r cosine theta plus 2 times r sine theta plus 1 is equal to 0. Okay, so first thing we'll do is subtract 1 from both sides. So we'll have 5r cosine theta plus 2r sine theta is equal to -1. And like I said, I'm going to solve for r. So I can factor an r out of the left. So I'll have 5 cosine theta plus 2 sine theta being equal to -1. And then I'm going to divide both sides by this expression, 5 cosine theta plus 2 sine theta. And this is not going to be a super nice answer. Okay, so we'll have r is equal to -1 divided by that quantity. And it does not simplify. You might be thinking, well, I'm dividing by cosine secant, but because of this addition, right, you can't just split it up. So that's actually the polar equation. So you're not going to be using the polar form for this kind of a line very often because that's very confusing. All right, now, this was just y equals mx plus b in general. If b is 0, you get kind of a unique case. All right, so I'm talking about y equals mx, and that's a line through the origin. Okay, so if we have this example, y equals the square root of 3 times x. All right, so that'll be r sine theta equals the square root of 3 times r cosine theta. And we're not going to be able to solve for r in this case. When you divide by r, it's not going to go anywhere. So what we're going to do is actually try to solve for theta. So here's what we can do. We can divide both sides by the cosine of theta. So the strategy is we'll get all the trig functions on the same side. And sine divided by cosine of the same angle is the tangent of that angle. All right, so we have that the tangent of theta is equal to the square root of 3. And the square root of 3 is one of our special angles. So we are talking about that theta is actually 60 degrees, or we'll do it in radians, it's a little more preferred, pi over 3. That's the polar equation. So if you found all the points whose theta was pi over 3, or all the points whose theta value was 60 degrees, they are all going to be on a line going through the origin. All right? And that includes the actual origin itself with r equals 0.